Okay, if you have the Simple Machine, the screw jack for the Simple Machine Lab, this is probably the easiest one to do, so congratulations on that. However, it is probably the most hazardous, so you have to be somewhat careful with a few of these things. First, you're going to need a 1 kilogram mass. You're going to get a screw jack with the string attached to it. You're going to need a 0 to 2.5 Newton spring scale, and then you're just going to need a ruler. So first thing you're going to do is determine the IMA for your screw jack. So to do that, we have to measure the distance that rope is from the center of that axle, and so it looks like that's about 4 centimeters or 40 millimeters away. And then as this thing operates, it's going to spin all the way around like that. You're going to have to get the circumference of that, so 2 pi times whatever that distance is for that rope relative to the axle point. Now to measure the pitch, P represents the distance between those threads. Probably the easiest way to do that is to disassemble this thing. I'm going to set the phone down for a second. So once I set that phone down, you can see I pulled out that thread, that center axle. Probably the easiest way to do this is set your ruler here and maybe measure, maybe count the number of threads that occur between maybe 0 to 20 millimeters, right? So that says 2 there, but that's really 20 millimeters. So if you maybe count the number of threads there are between 0 and 20 millimeters, you would take that 20 millimeters, divide it by the number of threads that you count, and that would give you the distance between an individual thread. Okay, so once you do that, you can calculate your IMA. I'm going to set this down and put this back into the screw jack base. Okay, now to operate this, the screw jack has to turn counterclockwise to lift it, right? So make sure that the device is going to be turning counterclockwise. The goal here is you have to balance this 1 kilogram mass on top of this, and this can be somewhat challenging to get it so that it doesn't topple. If it does topple, it's going to create a heck of a racket on the table. It could also really damage your fingers, so be very careful with that. Now, I'm going to take the Newton scale, and I'm going to try to do this with holding my phone in hand. I have to connect this thing up to that rope. I'm going to set this down for just a minute. Okay, so I'm going to connect this thing up with the Newton scale, and I'm going to try to read as I pull this thing. I'm trying to measure how much input force is needed to be able to lift that, and so I can see that I'm starting to turn it, but what I have to do is I have to read this value as I'm turning it, and I'm going to read this in grams instead of newtons. And the reason for that, I am moving it here, is reading in the neighborhood of 25. You really have to be somewhat accurate or meticulous with this to be able to get that reading. And again, I want to make sure that that rope is always perpendicular to it as it moves. So if I start doing this, then it's going to give me faulty values. So I want to try to move this thing along and read how much required scale reading I have for here to be able to get this thing to move at a constant speed. Okay, so something along those lines, you would get that value, and sure enough, that's when that mass falls, creates a heck of a racket. Once you're done, just go ahead and return your equipment to the appropriate space. Again, a fairly simple setup here. The biggest danger is just with that mass on top of that screw jack. We don't want it to fall off and injure your fingers or create a heck of a racket on the table. Okay, so there we go.